Hello dear students, I am Samir Velankar and here is the second video on the topic data structure. In this video, we will see what kind of data structure is linked list, and we will also compare linked list with array. We will know its advantages and disadvantages. Actually, linked list is a data structure. If I tell you that linked list is a data structure, you must understand that linked list will store data, period, full stop. Next time, whenever I say stack is a data structure, then you should understand that stack stores data. Or queue is a data structure, then queue stores data. Basically, anything which is a data structure stores data, and the arrangement of data is specific. Every data structure has its own arrangement of data. So linked list has its own arrangement or its own method in which it stores data. Let's imagine that the data that we want to store is, let's say, 10, 10, 20, 30, 40. That's it. Very simple data. Then what we do for creating a linked list is we create a node structure in the memory. Now this node structure created in the memory is created by using malloc function or any method which can dynamically allocate memory is used for allocating that node. And this node has a member which can store data and has a member which can store a pointer called next. Now, such way we have got four data values, isn't it? Now, what we do is we will allocate one more node in the memory, one more node structure using malloc, which can again store data and next pointer called next. In such a way, we will allocate four node structures. Each node structure will contain data and the next pointers. Now, definitely, if this node structure is stored in the memory using malloc, then it will have some address where the node starts. Let's say address of each node is 1000, 2000, 3000, and 4000. We are assuming these are the addresses. Okay. Now what happens is the next pointer stored inside node 10 will literally store 2000. Look, what is this next pointer storing? The next pointer which is stored in the node 10 is literally storing 2000. That means next pointer will point to the address 2000. What that means is the node 10 is actually storing address of 20, the node 20. Similarly, the next stored inside the node 20 will literally store 3000, which is address of the third node. And the next pointer of 30 is going to store 4000, which is address of the fourth node. Now, by the way, next pointer of 40 is going to store a special value called null. I usually show null with a ground symbol. Actually, null means empty, nothing. So if next is nothing, that means the next pointer of 40 is not pointing anywhere. It is an empty pointer. The diagram which I have drawn is called linked list. So what is linked list? Linked list is a list. Yes, it is list of node structures. It is list of node structures. You just see that there are four nodes here in the above linked list. So linked list is list of node structures linked, that's the word, linked using pointers. So every node has a pointer to next node. That's how these nodes have been linked. Additionally, we will have one more pointer called first, or any name can be given. And first is a pointer which will always point to the first node. So this first in this example will be 1000 because you are watching that address of the first node is 1000. Now in this entire discussion, in this entire discussion, what is most important? You may say, sir, data is important, 10, 20, 30, 40. Yes, of course, data is important. But in this linked list, the most important part is the first pointer. Check how important this first is. Now, if you want to traverse this list, if you want to go to every node one by one, if you want to visit every node one by one, then you better contact first. First will tell you address of the first node. So you can visit the first node because now you know the address of the first node. After visiting first node and working with it, after working with first node, you can know address of the second node because next point's address of the second node. So you can visit second node, and second node will tell you address of the third node tells you address of the fourth node, and fourth node says that there are no more nodes because my next is null. So for some time you imagine that the first pointer was not there. If the first pointer was not there, then you lost your linked list. This linked list cannot be visited at all because if you don't know address of the first node, how come you will know address of the second or no address of the third? You won't know anybody's address and you cannot visit any node. Very silly example. Let's assume that you have 10 friends in this city and you are new to this city. You have never came before in this city and you don't know anybody's address, but you want to visit all your 10 friends, isn't it? And you happen to meet a stranger who is not your friend. You happen to meet a stranger called First. Assume First is a stranger, and this stranger tells you address of the first friend. Great. You visit the first friend, and first friend tells you the address of the second. Second tells you address of the third, and then you visit the 10th friend, and 10th friend tells you there are no more friends, isn't it? So, who was most important in this discussion? Was that stranger? Yes, the stranger who was first, who told you the address of the first node staying in the new city for you. So, that's linked list for you. Linked list is list of node structures linked using pointers. Now, if you compare this linked list with an array, note that data given was 10, 20, 30, 40. This is the data. Now, anybody would say, sir, why are you using such a complex data structure? We can easily store this data in an array. And from the lower semesters, we have been comfortable with arrays just storing the data sequentially. Anyway, linked list also stores data sequentially. It stores 10, after that 20, after that 30. So it is still storing the data sequentially, just as in the case of array. So why don't you use array? I have no problem with arrays. Arrays are still a better data structure, very nice data structure, but sometimes linked list is preferred over arrays. Now why? What's the problem? Now the problem is, in any C program, when you declare an array, you write the data type, you write the name of the array, and you write the size of the array, isn't it? Now just imagine in your program you have declared an array of size 4. Okay, then you have got array of size 4 as I am redrawing it. That is 0 to 3 locations you have array of size 4, and you use it in your program, you store the values in the array. But suddenly you realize that you want to store one more value in this array, but one more value cannot be stored. You watch, after 10, 20, 30, 40, you can't store any other value because all 4 locations of the array are full. That is, size of the array was 4 and you have filled 4 locations. So you cannot store additional values. If you try to store it, you may get memory error. That means arrays always has fixed size, have fixed size. So some students might be thinking, okay, you wanted to store more values, fine, then why don't you declare a bigger array? I don't have any problem. You declare a bigger array, say 40 element array. Now the array is too big. But then what if you want to store more than 40 elements? Suddenly, after declaring the array, you can't increase the size of the array. That's my point. Now this program will continue to have size 40 as far as the array is concerned. And somewhere in between the program, while the program is running, you can't increase the array size dynamically. You can't say that our program started with the array of size 40 Now I want to increase the array size to 50. It's not possible, isn't it? But that's not true with linked list. Although array have fixed size, linked list can grow or shrink. You notice the linked list drawn above 10, 20, 30, 40. Now just imagine we want to add 50 to this. So what? What's the problem? What you do is you create a node in the memory using malloc. So you ask malloc to allocate one more node which can store data. Let's store the data as 50 and the pointer called next. Now this 50 is going to have next as null because this 50 is going to become the last node. But 40 is next, which was null, will no more be null, but it will point to the node, newly created node, which is 50. So easily we have added a new node. The only limitation to linked list is if the memory becomes full, then you cannot allocate a new node using malloc. Malloc also will fail. Malloc will say, I can't allocate memory for a new node because memory is full. But that's very far from reality. At least I have not seen that memory becomes full. But who knows? Once in a thousand case it can be, then linked list also will fail, saying insufficient memory. But as far as array and linked list are concerned, linked list can grow in size, isn't it? Like if I have one more node, so what? I will allocate space for a node using malloc, store the data, ask next pointer to become null, 60 is next is null, but ask 50 is next to point to 60. So this can so easily increase in size, isn't it? Secondly, the problem with array, coming back to arrays, suppose we have 10, 20, 30, 40 stored in the array. As you are watching the diagram of the array, we have these four values stored in the array. And suddenly, I don't know why, but we want to delete 20. We want to delete this value from the array. The problem of array is that you just don't have an eraser. You just can't say, I will scribble, I will scrap this value 20 and then I will reduce the size of the array to 3 because 20 is not there. This is not possible. What you will have to do is to delete 20, you will have to copy 30 on top of 20. Then you will have to copy 40 on top of 30. And then you will have to say the array is still of size 4, but 40 is like a garbage value. I'll redraw this again. I'll redraw this. What we are discussing, you please try to understand. Deletion of an element in an array is very complex process. How come it is complex process? If we have an array which stores values like 10, 20, 30, 40, 0, 1, 2, 3, 4 are indices. And if you want to delete 20, then there is no way that you can delete 20 like that. There is no eraser. What you will have to do is you will have to copy 30 at the first location. So first location will be 30. You tell me if the first location is 30, 20 is not there anymore at this location. So it is as good as we have lost 20, isn't it? But then that 40 will be copied on top here on the second location. This is 40. And then we will say that now the array holds 0 to 2 values, but not that third element is not there. Third element is still there. This 40 is still there in the memory, but it is wasted. And we will say this much array 10, 30, 40 are my valid locations, and the next element 40 is as good as garbage. So can you imagine an array of size 1000 and we want to delete one element? So many left shifts we will have to do. Just check, values are to be shifted to the left, like 40 was 30 was shifted to the left, 40 was shifted to the left. Lot of left shifts will have to be done. Now coming back to the linked list, just assume that we want to delete 30, the node 30 which I am striking out. Now deleting 30 is so easy. The 20 is next. The pointer next of 20 was pointing to 30, but 30 is to be deleted. Then we will simply say 20's next pointer should point to 40. Just check this. If 20's next points to 40, then 20's next. Then 20's next will not point anymore to 30. Have you agreed that? Just check. 20 is next, is now pointing to 40. We will do this pointer adjustment. Then 30 is deleted. You would say, sir, 30 is still there. Yeah, I can see 30. The node is still there, but 30 is logically deleted because you can see that first will take us to 10. 10 will take us to 20 as you observe the links, and 20 is next will now take us to 40. So where is 30? 30 is bypassed, isn't it? So 30 is as good as deleted. That means deleting a node in a linked list is so easy as adjusting some pointers, whereas deleting a value in an array requires lot of readjustment of the values. You will have to shift the values towards the left, continue shifting them towards the left, but there is no adjustment. Data is not at all moved in the linked list. Simply the single pointer, one pointer was adjusted. Just as deletion, insertion is also very difficult in an array. But that becomes very easy in a linked list. Although we are not learning insertion here, note that this deletion process will be learned in detail in our upcoming videos. Or creation of the linked list, the programming of linked list will be learned in detail. But I am giving you a foresight of why we should go for a linked list and many times why we should avoid arrays. If your application, just imagine you are writing a program in which you will store some data and then every now and then you are deleting some data. Suppose if you know that while the program is running, most of the times data is going to get deleted, then I will advise you to use linked list instead of arrays, because deleting a data in an array is going to be time consuming. Not true with the linked list. In linked list, you just have to adjust one pointer. Also, if suppose you are writing an application in which you don't know how much data is going to be there. Somebody says n values or n data elements are going to be there. So you really don't know how much data will grow, how many data will come in. Then I will advise you to use linked list, because as the data comes in, new data comes in, you can just keep allocating new node using malloc. There is no limit to this, and the linked list can grow, isn't it? But the array cannot grow. Once you declare an array of size, say 1000, then that array will continue to have that at that size 1000, and then you can't store more than 1000 values in the array. So linked list is sequential data structure, array is also sequential data structure. But we have noticed how linked list differs from array as far as appearance is concerned, isn't it? Appearance wise also it differs, and operation wise it is better as far as insert and delete operations are concerned. Thank you very much.